Hey guys, welcome. I can clearly see that in last few seconds, right? Last few seconds, almost 12 people have joined us. Almost 12 people. Okay, that's great. So guys, welcome again to this session or this webinar on, Spark. When we say, why we say, first of all, that, beyond Hadoop and Mapreduce, and is it really so? And if it is, then what are the implications and all, right? So few of the things, it's worth spending 1 hour to, discuss about some of those things, see some of the things, what exactly does it mean, right? And yeah, if that adds some value in your existing, knowledge base, that would be one of the most pleasing things for me, right? Introducing myself, you can see presenter is equal to Vishal here. So my name is Vishal. Uh, and when it comes to the overall years of experience, it's now more than 12 years of experience, which out of that, I would say since last more than 5 years now into the area of big data, I would say, because when I started my journey at that point of time, Hadoop was in its infancy stages. I mean, like the only documentation which was there was just some of the Java docs and all. And yes, and then that's how it, evolved over the period of time. Went into some of the other technologies. Spark is later, the later development, but before that, Storm. There are a few things like Samza, etc., wherein I had to work. So now, at present, when it comes to that, I'm more into the implementation of, if you have heard the term called Lambda architecture. It's primarily the coexistence of your batch processing or big data batch processing systems with the speed layer or hot layer, where you call that, and that speed or hot layer typically comes with Spark or some of the, its competitors and all. And yeah, that's pretty much of it. And of course, the coexistence with the legacy system. In terms of the different domains and also primarily into the retail and banking, there are few projects of healthcare domain as well as telecom which I've done, but well, they are negligible as compared to the experience which I'm having in these domains. I think that should be good enough as an introduction, right? But yes, well, this was about me. More than my introduction, I would definitely be interested in knowing your introduction. Very quick, of course, I can see your names, right? So if you could just tell, let's say, which domain or, which platform are you working in, that kind of, number of years of experience, if you just type. Of course, it would not be possible for me to read out everything, but I'll try to, see some of the latest messages here. So I do see somebody, Sandesh, who's having 2 years of experience. There are guys who are working on HANA. I'm referring for Anish. Samir is there, who is 10 years of experience in the area of ETL. There is Michelle, who is having almost 9 years of experience, and that's primary into the area of core Java development. That's great. And then I do see Rohit, who is having almost 4 years of experience in ETL. And yeah, Abhishek is there with us, who is having almost 7 years of experience, and he's a tech lead in Samsung. There is Don, who's present here, who seems like he works for Gap Inc. And he's having, he's having almost 18 years of experience overall. And I think the senior most guy among us. There is Amul, who's having 16 years of experience in IT project management. So of course, it's such a diverse, audience altogether. Quite nice to know about you guys. And as I can see clearly that it's quite a good mixture of people from different backgrounds, different years of experience altogether, right? Please forgive me if I kind of, let's say, missed your, introduction or this thing, because in the interest of time, I just handpicked some of them, right? So guys, great. Now, this was, I hope it has acted as a icebreaker also for this audience, right? Even though you are connected remotely, it's always good to know about the other guys, right? Okay, so let's just get started, right? Uh, so what are the things which we have in plan, right? It's almost like 9:37 India time, before 10:30. What are the things, you know, which we should actually be focusing at that, right? Uh, some of the things which are, just a sec, guys, I hope everybody is able to hear me loud and clear. Am I right? Great. Okay, Praveen and few more guys who were not able to, guys, it might be the problem at your end. You would probably like to log out and log in. Okay, so just going ahead, and thanks for the sound check, because sometimes these are the, you know, end user problems also. Okay, so coming to the agenda, coming to the topics which we plan to cover is, well, here the assumption is, of course, since you guys are coming to a webinar and all of us are smart enough, we would have done some of Googling, or probably we might be having some of the experience. We must have heard about Mapreduce, right? So here, of course, we are not trying to understand what exactly Mapreduce is. I'll take that basic assumption that you know it. We'll talk about the strengths, right? It's always good to start on a positive note, always, right? And well, it has its own strengths, but then there are some of the boundary conditions. There are some of the limitations also which are there in MapReduce. Of course, that must be a logical thing, because if there would not be any limitations for it, probably this kind of webinar would not even be happening, right? The only reason due to which we are talking about some of the alternatives of MapReduce, or some of the, you know, things which might replace it, right? It's sheerly because, you know, the sheer reason might be some of the limitations. So we'll try to see different looks, and I'll try to provide some of the practical aspects wherein we have in workplace also we have faced those, you know, kind of situations, desperate situations altogether. Those limitations, how they can be overcome, or how exactly Spark is actually fits into the bill, wherein you talk about those limitations and how exactly Spark helps you to overcome most of them. I'm not saying all of them. I'm saying most of them. That is something which is the, you know, matter for the next two topics. And then other exciting features, well, I would call it as miscellaneous. I'll call it as, probably at that point of time we'll be doing a kind of a, you know, I'll be able to tell you about which components of your Spark ecosystems are being used very widely in companies. So it's not like, you know, you use everything, right? You must be using one component of the ecosystem which is applicable to your use case, right? So we'll be talking about that, which kind of, you know, adoption is there. Well, I'm not sure how many of you have attended the webinars or, you know, the courses from Edureka earlier, but I hope those people who have attended it earlier must be able to recall that the USP of these webinars is hands-on. What's the point of delivering? What's the point of, you know, talking on something wherein you can't walk the talk, right? I hope everybody understands that part, right? So this is also not going to be without some sort of hands-on. So in order to do that, what I'll do is, after completing all this, we'll go to the machine, right? And I would like to do a comparative analysis between MapReduce and Spark. Whatever we just talked, let us see it in practice, right? And what we'll do is we'll use, or we'll run a simple program, you know, in MapReduce on the same machine on a good amount of data set, and then the very same program on the very same machine on the very same data set in Spark, right? And let's see the performance difference, right? So it's like comparing apples to apples, right? So looks like a good type of investment, good investment of your time to everybody. Are we good to go? right? I hope this makes a logical sense to everybody here. Great. Thank you. Thanks for confirming, guys. Okay, so I hope everybody is able to see the screen wherein it talks about the strengths of or strength of Mapreduce. So some part of it either is already known or probably you might already be experiencing it in your workplaces, right? So the first thing is simple, though I say that simple is a relative term because that depends on your skill set level also, right? So, but yeah, assuming that a normal condition or a good kind of, skill level altogether, MapReduce is simple after all. Because as far as you know the paradigm, as far as you know the paradigm of MapReduce, that every problem has to be expressed in the form of key and values, you should be able to solve the problems in, in the form of MapReduce programs. So doesn't matter whether you are coming from the background of Java or C++ or Python, doesn't really matter, or even R, or I mean, I had to write the programs even in Scala as well as in JavaScript also. I have written the MapReduce programs in JavaScript as well. Okay, so the crux of the matter is, if you know the paradigm, then you might be coming from different kind of programming background or different kind of language affinity. It doesn't really matter. You can code your you can code in MapReduce or in the MapReduce paradigm altogether, right? That is one of the biggest thing, and this is one of the prime reasons of wide adoption of MapReduce in the industry after all, right? Because if you cannot communicate with the masses of different background, you cannot gain the widespread adoption. The next part is scalability, right? And again, when we say scalability, we are talking about horizontal scalability. We are not talking about the vertical scalability, which is actually the limitation factor, right? So it's horizontally scalable altogether. You need more processing power, you need more data storage, add more nodes. It's not like you keep increasing the strength of a single machine, right? It's well known. I'm not speaking much on those lines. There are some more interesting topics. It's fault tolerant. We all know about it. That's the best part of MapReduce, isn't it? Because you run your job, that's what you're supposed to do, right? You're supposed to focus on the business logic rather than thinking, oh, okay, now my job is running on 20 machines. Well, on 18 machines it succeeded, but on 2 machines it failed. What am I supposed to do? Should I take it as a failure? Should I take it as a success? Or should I rerun those 2 jobs? That headache is something which is not the job of a programmer. It's the job of the infrastructure. And that's exactly where Hadoop or MapReduce actually helps you. You write your logic, and then if there are failures, partial failures, let MapReduce to take care of it, until unless it is your genuine problem. You have written the code in such a way that it is supposed to bomb. Then it's a different case, right? So those kind of things are taken care by MapReduce paradigm altogether, right? Or MapReduce framework altogether. I was wrong in saying paradigm here, okay? And then it's about minimal data motion altogether. So it's always about that, the principle of data locality. That's how I will summarize it, right? And it's not only, by the way, Hadoop principle, it is the principle of any distributed system in the world. Be it Hadoop, be it Spark, be it Storm, be it Samza, be it Cassandra, whatsoever you talk about it, they all follow the principle of data locality, right? So here the process goes to the data rather than data going to the process, right? So that's a big game changer altogether. And that's where the data movement happens in the minimal possible fashion altogether, and that's what makes MapReduce faster. very fast, I would say. But again, when I say very fast, so the definition of fast is 500 GB data getting processed in 1 hour. That is the fast thing. Or let's say not 1 hour, probably 35 minutes, something. That is the definition of fast, right? So this is actually the, you know, playground. This is the typical playground of Mapreduce, right? Before I come to the limitations of Mapreduce, because again, when I talk about the limitation, the idea is not to downgrade or to show Mapreduce in a bad light. Mapreduce has its own ground, its own use cases. For example, let's say you talk about a batch process, right, which is running in your company altogether, right, which is running in your company altogether. Now, who cares if your job runs in 2 hours or 2 hours 20 minutes? If this is the case, you don't need to move away from Mapreduce if this is the case. But if 2 hours and 2 hours 2 minutes is probably gonna raise some management notes and all, if that is the sensitivity, you better move away from Hadoop. You better move to, or rather than Hadoop, better move away from MapReduce part of it. Go to something which is more time sensitive, right? And hence, whenever you will have those kind of scenarios, or there are several others, okay, there are several others which I'm going to talk now. Those will be the natural cases wherein you will try to find out the replacement of MapReduce. Whether that replacement is Spark or something, we can decide it later. So I hope it is very, very clear to everybody, right? The strengths of MapReduce, its use cases, and the place where probably you would like to see something better. Are we all good up to this point? So there is a question, I think there is one question wherein say all the MapReduce code is in Java only. Vikas, probably, so this is a question from Vikas Mittal. Vikas, I'm not sure whether you were able to hear me at that time. I have written the code of MapReduce in Java, in Scala, in R, Python, Ruby, JavaScript, and C++. 7 languages at least. I hope you got the answer. Right, Vikas? But in slide it is saying, hold on, where exactly is that? Here, see this? Independent of programming language such as Java, C++ or Python. Right? I hope it is clear, right, Vikas? It is independent of the language, right? It doesn't really matter. And that's what the point is, right? I hope we are on the same page, right? Okay, with that, let me just move ahead, right? So, yeah, I was at the point wherein I was talking about the, now I'm going to talk about the cases wherein probably, or not probably, most surely, you would be looking ahead of MapReduce. That would be the, so these are some of the use cases, guys. Let me start right from the top, which talks about real-time processing. Well, it's a different point that real-time has a different meaning in the traditional world versus in the big data world. This webinar is not the right place to discuss on those things, but all I would tell you at this point of time is real-time processing in big data world is almost kind of a myth, okay? Or at most what you can have is near real-time processing. You talk about any solution in the world which talks about real-time or which claims to implement Lambda architecture, right? They typically talk about the near real-time, and when they say near real-time, probably sub-second sort of, you know, or let's say in the order of few seconds, 1 to 3 seconds sort of a response time. That is what they call it as real time, okay? Whereas in the OLTP world, it has a different meaning altogether, right? So I hope those guys who have experienced these things, right, So who have experienced these things can easily correlate with that. But yes, the point here is wherever you have the requirement of sub-seconds or at max 2-3 seconds sort of response time, Hadoop is not the best place. Hadoop is not the best place for that, right? Because just the overhead of spawning your jobs, monitoring it, getting the response back, this itself takes at least 10 to 20 seconds of time, right? Depending upon your cluster size also. Second, graph processing. Okay, how many people in this webinar have worked on Mapreduce? How many people in this webinar? You can say yes if you have. So have coded in Mapreduce. Okay, I can see only 3-4. Not everybody at all. There are almost 100 people. There are only 3. Is that it? Okay. So guys, those very few people, almost I would say I don't have the success rate of more than 3-4%. So guys, those people who say that they have worked in Mapreduce, if I ask you a question, is it possible? Is it possible? So I'm not asking you any coding thing here, okay? I'm not asking you that tell me the code. I'm asking you the algorithm. Is it possible for you to do breadth first search or depth first search in graph? If I give you a graph, can you perform a depth first search in Mapreduce? Can you do that? That is a question. And this question is open for all those people or 3-4 people who said yes. Or next question, okay, next question to you. And these are my favorite questions, by the way. I ask people when I take interview who claim that, you know, we have worked on it. The next question is, so you all know about sequence, right? Sequence, anybody who has worked on the databases? I'm sure everybody is aware of the sequences, right? The whole sole purpose of sequence is to produce the next number, right? I hope everybody agrees with me. Sequence. Can you implement the sequences in Mapreduce? What do you guys say? So this is a different question to you. Can you implement the sequences in Mapreduce? And when you say no, I would really appreciate if you just, you know, in a line, you can just tell me why. Why do you think so? I hope guys, you guys are liking this style of interaction. I don't really want this webinar to be monologue. I want to interact with all of you. So people say data is distributed across nodes. Exactly. So probably the way, you know, people are responding, I just want to summarize it, and I just want to say that guys, the only reason which is stopping you is that every next operation, whatever you are trying to do, needs to know what happened previously or what will happen next. Am I right? Am I right? And that is something which is not guaranteed in the distributed world. Am I echoing your emotions or your views? Right? For sequence file. No, I'm not talking about sequence file. I'm saying sequences. Right? Okay. So guys, that's the main thing, right? By the way, the answer of both of the questions, whatever I just asked you, the answer of both of the questions is yes. Okay. Okay, so the answer of both of the questions is yes. You can implement a sequence as well as you can do the breadth first search. However, the moment as more entire class, or sorry for saying it as a class, it's a audience, as entire audience has responded that it is the answer is no, for according to you. The reason is they are not straightforward solutions. In order to do graph processing, you have to use something called iterative MapReduce. I'm not sure how many of you actually had to go into that pain. I had to. Okay, so there is something called iterative MapReduce. That is something which you will have to apply. Otherwise, you will not be able to process the graphs at all. Okay. Uh, then the question comes about sequence, right? Again, I can give the entire solution, but the solution key lies in the effective implementation of your counters, because they are the only way of maintaining global states. I hope those people who are aware of counters, they can easily correlate now, right? So anyway, now just coming back here, so graph processing. I hope now you understood that where exactly we are talking about the limitation. Graph processing is one of the very real use cases, right? In machine learning, you cannot do that. Complex algorithms. I just give you the example. DFS, BFS, Fibonacci series, that is another case. Matrix multiplication, right? Talk about these things and you try to do it in MapReduce. Road is not easy. Or even if you apply it, there are so many hacks which you will have to do. Okay. Next, basically HDFS, right? HDFS. What is HDFS? The main characteristic of it is it's a worm system. Write once, read many times, right? But the problem here is if you have to do multi passes of the data, okay, multi pass of the data, as it happens many times in machine learning algorithms. I hope if you have heard about machine learning, k-means clustering, collaborative filtering, etc., etc., they require you to go through the data again and again and again, right? 20 times, 50 times, 10 times, depends, right? What kind of accuracy you are looking at, right? So these kind of algorithms want you to go through the data again and again, these are the multi-pass algorithms altogether. MapReduce is not designed for that at all, not at all. Or random access of the data. You have 10 billion records. You want the data of user ID, some million, some hundreds of thousands or some number, right? This is a random record. Try to get that. You have to scan an entire record. There is no way you can just go to that particular record unless you are using HBase. Okay, so these are the practical limitations altogether, right? You have 10 billion capacity, fine. I need only one. Oh, don't tell me that for one record I have to go through 10 billion records, right? This is not what people are looking for, right? So all of these cases actually, fortunately, unfortunately, depend which angle you are looking at, but they are the real use cases and they are not supported using MapReduce. MapReduce doesn't support them at all. That's where Spark comes into picture. So now that when I move towards how exactly Spark fits into the bill, why don't we just start with one of the benchmarkings altogether? I'm sure those kind of questions must be forming in your mind. Vishal, what is making Spark so powerful? What is making Spark or why are you saying that Spark is going to solve these problems? I'm moving towards that direction slowly, but it's like half time sort of. At this point of time, I would like you to spend few seconds on this slide, which is kind of comparing it, right? So TerraSort, there is a algorithm called TerraSort. Okay, basically it's all about total order sorting, right? Of huge amount of data, and huge is equal to 100 terabyte for now, right? So in 2013, when Hadoop achieved it, that's a record anyway. 72 minutes. In 72 minutes, they sorted entire 100 terabyte data using 2,100 machines. Just 1 year later, when people started, using Spark, the next figure, which is in orange color, 23 minutes. It's not less. It is far, far less, by the way, right? 72 versus 23 minutes. But the most striking part is, can you see the number of machines? Only 207 as compared to 2,100 machines, right? So what are you seeing? You're seeing 100 times, almost 100 times faster. So this, please don't go by the number. It's not a marketing call here, right? So it is almost 100 times faster, not always true, because depending upon which kind of operation you are doing, right? Whether you are doing IO heavy operation or whether you are doing some sort of, let's say, CPU heavy operation, right? That is a different call, right? But up to almost like 100 times faster than Mapreduce, if you just look at this example. The other part is, you are seeing that machines which are being used are 10 times lesser, right? Actually less than 10 times lesser, right? Now, Hadoop, Mapreduce, basically Hadoop itself is written in Java. Okay, Mapreduce can be written in any language which can fetch the data from stream. Spark itself is written in Scala. It is preferred that you write your Spark programs in Scala. However, as of now, Spark programs can be written in 3 languages. One is Scala, one is Java. We don't encourage Java for Spark because your programs can be painfully longer, because you typically need the knowledge of functional programming, by the way. Okay, so Scala is better fit, or you can use Java 8. If you really are a Java person, use Java 8. Start using streams and other features of it, right? And then the third language which is supported is Python. There is active development which is going on. That is for the 4th language. And the 4th language is going to be R, which is a statistical programming language. So as of now, Spark supports the programming in all these 3 languages. 4th one is kind of, it is still WIP, work in progress, right? I hope you guys got some idea, right? So you already know by now the limitations of Mapreduce, right? Now, I'm sure I have done a job of at least generating some questions in your mind, if not answers, right? What is it which is making it fast, right? So let us now move towards that part wherein we talk about overcoming of these limitations and what exactly happens there. Well, let me not spend much time on this slide because this is more of a caricature and there are better things to talk rather than just the caricature part of it, right? So few things, the main blocks for you were the multi-passes of the data, and multi-passes were painful because every time you were hitting the disk, right, you are hitting the hard disk for fetching the data. Not sure how many of you are from the admin background, but probably if you replace your spinning hard disks, right, which are there, to SSDs, of course, at a bit more cost, quite a bit more costly prospect, you can probably get quite a good performance. But again, there is always a penalty when you try to get the data, try to fetch the data from hard disk. Okay, Spark overcomes this limitation by the concept of something called RDD, R stands for resilient, DD, distributed data set. Resilient distributed data set. Okay, so this is something which is the backbone, by the way. Okay, this is something which is the backbone of your all of the operations, whatever you will do. So remember, with Spark 1.4, okay, Spark SQL uses data frame, but before that, each and everything whatsoever you will do in Spark will be an RDD. It will be an RDD. Anything, right from creation of the data to manipulation or to whatsoever you want to do is an RDD. Okay, it's a resilient distributed data set. Now, what exactly is this, right? So, what exactly is this? Vikas, I'll answer your questions in a few, few more minutes. Let me just, talk about this part right now. Okay, so coming here to this part, right? So the RDDs, basically, what exactly they are nothing but just the memory abstraction or the distributed memory abstraction, which is there. So your SDFS, what is SDFS, by the way? It's the abstraction of the underlying distributed file system, right? It almost looks like RDD, right? When you talk about in memory. So it's like your memory is distributed on the nodes, and then their abstraction is called RDD. So for you, you would be reading the data from memory. Now, whether it is read from the memory of machine 1 or machine 2 or machine 10 doesn't really matter. So it's like, reading the data from the memory. And of course, it is definitely faster any given day. Whether you are using core Spark program, wherein you purposefully go ahead and create this RDD, or you are using something like Spark streaming, okay, wherein it is actually effectively just the, batches, okay, it is effectively the batches of RDD altogether, okay. So any operation, will have the underlying aspect as the in-memory abstraction altogether, right? And hence, that is something which is the reason of faster operations altogether. Before I move and I try to, talk about slide number 11, let me just, so there were a few questions wherein people said that, if we are using less machines in Spark, which is doing in-memory processing, does the machine use in? Yes, of course. So guys, it's so Vikas and others, is it like, it is simple that if you are going to use it for Spark, you need to upgrade your RAMs of the, cluster itself. That is for sure. But it is not always possible also. Okay, it is not always possible also, and hence, so coming to Abhishek and few more guys who have asked about this question, in that case, Spark gives you the option of keeping the data some part in memory, some part in disk. That gives you the tunability of the performance. Okay, so Spark allows you to do that. Plus, Spark keeps the lineage of the data. Okay, so in that case, let's say if there is a machine failure or something, Spark uses a concept of lineage to recover the data. Okay, this is the fastest I can answer your queries, guys, right now. Right, I hope, guys, if not direct answers, you must have got the directions of your answers, right? Abhishek, Vikas, right? Don, everybody, right? Sure. Now let me just continue there, right? So, and the same thing goes for, the machine learning library. For streaming, there is a library. For graph processing, there is a library, and all of those libraries are using underlying, caching capabilities. So even if you have to read the data multiple times, you are always reading it from machines, which is almost 100 times, 500 times faster any given day altogether, right? So those are the things which are, which make Spark really, really powerful. And this is how the Spark ecosystem looks like. This is how it looks like. Wherein, if you talk about it, at the bottommost layer, you have the core or Spark core engine. In fact, in our course of Spark and Scala, I'll definitely point you there at the end only. Okay, so we do a lot of things with Spark core, and at that point of time, its core engine, it's written in Scala. We, in fact, in Edureka, we cover as of now the things in Scala language. Okay, so we definitely cover Scala language also as part of this course. I'll come to that later. But yeah, coming to this particular point, this Spark core is into, you know, so you, if you want to write your own apps, you'll be hitting Spark core engine altogether. And then, just like Hadoop ecosystem, you know, one of the main strengths of Hadoop ecosystem, apart from scalability and other part, the main important thing is Hadoop has got the wrappers, right? So there might be some, there are, as in this session itself, there are so many guys who are from warehousing background, right? You are not aware how to write Mapreduce program, but you have spent almost what, 10 years, 12 years? Do you really care? Frankly speaking, do you really care to learn Mapreduce? Until and unless it is mandatory for your job, probably you would not like to. This is the honest answer, right? Now, that's the point wherein they have developed the wrappers, right, guys? That's the point wherein they have developed the wrappers in the form of Hive. So Hive is the SQL interface wherein you write your queries and internally they get converted to, you know, Mapreduce programs, and then for you, you are just working in SQL, but underlying thing is Mapreduce. So what is happening? You are not changing your platform, at the same time leveraging the power of Hadoop for your analysis, right? That is what makes Hadoop popular. In the same way, right? In the same way, when it comes to Spark SQL, it's the SQL phase, right? So you have to do structured data analysis, use Spark SQL. Spark streaming, it's for the streaming kind of data. MLlib is for, it's a machine learning library, though it is coming up, and actually it should have been in the orange color, by the way. Okay, and graphics as well. So MLlib and graphics are the libraries for graph processing and machine learning. They are work in progress. They are not yet production ready. There are you know, developer versions of them which are available right now. Okay, so they are subjected to change, but yes, they would be, right? So eventually, using MLlib graphics, you can create your own ML pipelines, data frames. They have introduced only in 1.4, Spark 1.4. Before that, it used to be called as schema RDD. Okay, so all of these things are, you know, the different phases wherein you can and then you can see on the top of this thing, you know, you can see Scala, Java, Python, R. These are the different languages. Well, R is still being developed. Okay, it is not like, you know, available. Only the data frame part is available right now. Okay, so this thing is evolving quite fast. Only thing is, depending upon which background are you coming from. Are you a data scientist? Are you an SQL person? Are you a core programmer? Or are you a person who is used quite a lot of streaming applications? You can use framework accordingly, right? So that is something which is one of the main strengths altogether. And exactly that's the part, right? Where be it random access, be it the iterative tasks and all. Well, all of that gets solved to a lot extent when you're talking about that you have to fetch the data from memory, right? So I hope it gives you good enough idea about what exactly happens there. And not only this, by the way, if you have ever worked in Pig, or if you have heard about how exactly Pig works, right? There, when you write the program, Pig creates the DAGs, right? Directed acyclic graph, right? directed acyclic graphs of the operations, whatever you do. So you say load a file, you'll say, for each, just take, just generates few columns, and then eventually do some filtering, grouping, blah, 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 10 operations. And then if you have paid good attention when your pig program runs, you would always see two things: Mapreduce program or Mapreduce plan before optimization and Mapreduce plan after optimization. What pig does is it just tries to put your operations and sees where can it optimize. Let's say you are doing 3 filter operations. Pig sees and tries its best if it can do all of that in a single pass. That's called the optimization part. But for you, you have just written different operations altogether, right? So internally, pig creates the directed acyclic graph of your operations, okay? Directed acyclic graph of your operations and does the processing. The same is true in the case of RDDs. So you explain you create your computations on the top of RDDs, and then Spark takes care of, creating a graph of them, optimizing them, and eventually executing them, right? Now, before I move to Spark features, which, basically they make it better, and the features which are there in demand, right? Let me just see, there are 1 or 2 questions altogether, and let me just try to address them. So does Spark load the data in the RAM instead of hard disk? Krish, yes, that is the right answer. Preferably, answer is preferably. If that much RAM is not available, you can put some data in RAM and remaining in disk. Okay. Next is, does Hive work with Spark? I know there is Spark SQL, but it is little different. So that the USP of Spark SQL is you can run the data or you can run the queries of Hive unchanged in Spark SQL, just that they will run way faster. Okay. Ajit says, how is RDD different from the distributed in-memory caching framework like Memcache? Ajit, answer is it is almost same. Almost same. Only thing is Memcache and other those databases are using it only for the storage part of it, whereas these things use it more from the perspective of processing and exposing it to the other forms, as you would have figured out by now. Right, Ajit? Crash, others, right? So there are some interesting questions wherein people say that we have Pig, Hive, Scoop, Flume, etc., which run in, Mapreduce. Can we have Pig, Scoop, etc., which run in Spark instead of Mapreduce? There are some of the projects which are going on. So I'm not sure how many of you have heard about Spark. It is actually Pig on Spark. People are working. There are some GitHub repositories, but they are not yet full-fledged projects. Okay, so Spark SQL of Spark is just like Hive for MR. Exactly, but just that it is many times faster, Samir. Okay. Now so I'm just moving to the last part of it, and guys, I hope you won't mind if I overstep my time by 5 minutes. Is that fine with you? Basically, my idea was to answer as many questions as I can, and instead of just talking from the screen, talk some concepts and, basically give some value, right? I don't want to end without hands-on. That's fine, right? With everybody, guys, quickly if you could confirm, right? So I would take, basically I'm telling you I'm going to take 5 more minutes of your time. Thank you. Thanks for confirming. Okay, so now coming to that point here. So modules in demand, or well, this percentage and all, don't just go by this percentage here. Let me just tell you the thing which is, of course, there is a widespread adoption is already for core API, because that is the most stable part. Simple as that. Next is streaming, because there is a lot of, kind of I would say competition with Storm. So people are evaluating it quite a lot. Spark SQL, MLlib, I think, even though it says probably it must be in the form of traction, but it is not there in the form of, let's say, production ready. Spark SQL has just become production ready. When I say just become, almost 1.5 months back. Okay, before that there was another project called Shark which was supported, and then it is closed. Now it is Spark SQL. Well, that's history bit, I'm not going there. So Spark SQL is another part, and then comes the machine learning and graphics, which are almost like they are in evolution, and then there is traction altogether, but they are in the form of the developer APIs, not yet production ready APIs, right? So these are the different features altogether. In 2015, this slide will talk about quite a lot of things. Let me just tell you the crux of the matter, right? In the interest of time, because I want to spend it on hands-on. So the biggest change which has happened as of now is there are two things. One, the integration with Hadoop. And when I say integration with Hadoop, basically getting the data directly from Hive. That is one big change. After that, they have actually closed the project Shark. Okay. Earlier, if you try to, let's say, you can go to Google and say Spark, and then go to page number 2, page number 3 of results, you will still see something called Shark. Okay. So Spark and Shark, it used to be called that way. Okay. So that is one change. Then the second change, which is even bigger, is they have now introduced data frames. If you are not aware of what data frames are, search for something called R space data frame in Google, you'll find. It's one of the most popular data structures of R, statistical language, which is kind of, let's say, you can think of it as an Excel sheet, right? It almost roughly represents a table altogether. Okay. So now what they have done is, instead of creating some data structure for R, then creating some data structure for Hive, then creating some data structure for some other data source, they have said let everything to be in data frame. That becomes your unified data structure for accessing any structured data there. Okay, so whether you are accessing it from Hive, whether you are accessing it for R, whether you are accessing it from pure Scala program, use it in the form of data frames, do whatever you want to do, your stuff, and then process the data back. It has big power. It is actually the game changer in case of Spark. So that is another part, Now, last, it's not the marketing bit here. So if that historical or just the theoretical part of it excites you, this is the place, edureka.co, Apache Spark Scala training. You can just visit it. In terms of so just in case if you are interested, Edureka, you can visit to this website, go to courses, Spark and Scala all together. If you'll click, you'll get to the home page, and then you can register, or probably you can even see what are the upcoming batches as well as curriculum part of it. Very few lines about that. Basically we cover it in the form of Spark as well as Scala. Okay, so we cover it in the form of Scala as well, and the course is divided in like half of the course talks about Scala to equip you to basically work in Spark, and then the remaining half portion is about Spark, wherein you start using those constructs basically in Spark applications. So that's all I would like to say, because as I told you, this is not the marketing pitch which we are talking here. All right. So guys, with that, are you excited to go to the machine and do some action? I am, and I am sure others at least would be interested to see the things, right? I'll try to wrap up as soon as possible. Just a second. My machine seems to be refusing to buzz right now. Hold on. So you can see a MacBook getting hanged. Why all data people use Mac? Any advantage over PC? No, crash. At this point of time, you can't see any advantage here, right? It is still hung. There are certain, but again, they are people can have their own. Guys, it's not. What's wrong with it? Give me a few seconds. Let me do a force quit. Let me start it all over Fusion. Okay. You need to give me few. You need to give me few minutes. What's wrong with it? Give me a second, guys. Yes. Now it comes up. And remind me later. Seems like, guys, it is gonna take few seconds. I'll just wait. Something has really gone wrong with it. Anyway, something seems to be wrong right now. I don't know. Good enough to run Hadoop and Spark? Yes, Mac. Make sure that you need to have almost, let's say, 8 GB RAM minimum. Internal error. What is that internal error? Hold on, guys. Cannot find valid peer process. Okay. Let me just try it once more. Valid peer process. Well, guys, the system is up to something right now. Let me just give one last try. Otherwise, I'll have to just see what can be done. Okay. Hold on. Remind me later. This, still loading. I'm so sorry, guys. This system right now is kind of limiting me. Let me just give a few more seconds. But anyway, I hate this. Yeah, because actually. So anyway, let me just tell you what exactly I was just trying to show. By if it just comes up, then well and good. Otherwise, you know, no problems there. Can't really help there. So idea here was basically the kind of demo which I was trying to do here is that you have a data, okay, which was like I was having almost like 400,000 records available to me, almost 400,000 records, and then those 400,000 records I would have run a simple word count program, you know, that hello world of big data world anyway, using Mapreduce. Okay, it would have taken, okay, it would have taken almost 45 seconds on the same virtual machine. Okay, on the same virtual machine it would have taken almost 45 seconds, whereas if I would have run the very same program on Spark on the same data set, same machine, it would not have taken more than, let's say, 0.5 seconds. Right? That was my idea. Only thing is right now I don't know what exactly is wrong here. Cannot find a valid peer process. This is like it just crashed. So that was something which was like, that's where you will see the power, right? Because 45 seconds versus 0.5 seconds, right? You can easily figure out what exactly is the ratio which we are talking about right now, right? So that was it, guys, but sorry, there's a machine malfunction, can't really help that. But I hope, irrespective of that, you got the idea about, you know, what are the main features or what are the things which make Spark better than MapReduce in its use cases. Right. Correct. So, sure. Thank you, guys. With that, right? And yeah, see you sometime, somewhere in some other webinar. I would have really loved if my machine would have worked here, but I don't know. Something is up with it. With that, seeing you now. Bye. Bye for now.